Okay, hi folks. Welcome to Ubuntu on WSL, an FAQ for data scientists and developers. This is a joint session between Canonical, who are the publishers of Ubuntu, and Dell Technologies. So we've got a really interesting group together to talk about this. I'm Oliver Smith. I'm the product manager for Ubuntu Desktop and Ubuntu on WSL at Canonical. And I'll let Jean-Baptiste do the introductions for himself next.
Okay, I'm Jean-Baptiste Lallemand. I'm the engineering manager behind WSL at Canonical. So I'm delivering this distribution to the Microsoft Store.
Cool. And Kyle?
You bet. It's a pleasure to be here, Oliver Jean-Baptiste. I'm Kyle Harper. I'm Director of AI Strategy for the Dell Precision Workstation portion of Dell Technologies. And it's a pleasure to be here. And we're excited about WSL finally arriving on the scene for AI work and data science.
Cool. Well, let's get started. So it's a bit of a high-level tour of WSL for this session. So we're going to start off with what is WSL, nice and simple. Who is it for? And then Jean-Baptiste is going to talk us through sort of how it works, the underlying technology. We'll have a bit of a breakout on WSL for data scientists. And then finally, we'll give you some tips on how to get started and where to find more information about Ubuntu on WSL. So yes, diving in, what is WSL? So Windows Subsystem for Linux. It's a Windows optional feature. It allows Windows users to run Linux command line tools, utilities, and applications directly on Microsoft Windows. It's available as a Windows component on Windows 10, and it's also an application on the Microsoft Store on Windows 11. So what that means is you can install various Linux distributions and start them directly from Windows in a matter of seconds, without the need for dual booting or starting a separate virtual machine. So really it's about consolidating these different workflows across operating systems in a way that's much more efficient. And with interoperability, users can run Windows executables from an Ubuntu shell, or they can run Ubuntu commands inside the Windows PowerShell. And they're doing all of that across a common file system. So who is it for? Well, really, it's for anyone who wants to use native Windows applications at the same time as developing, say, cloud-targeted applications in a space dominated by Linux. So if they want to run the same environment to develop as they're eventually going to deploy on, and anyone who wants to do that in an enterprise environment that is, typically managed by Windows. So you can think about that for web developers because they've got access to things like all those great Node.js workflows in Ubuntu. People who are doing CI/CD pipelines, they can test them locally before publishing to the cloud on an Ubuntu VM. Data scientists, of course, you'll hear a bit more about that. But the NVIDIA CUDA data science stack lets you sort of control the performance of your GPU inside the WSL instance. And then IT managers who just want a way of managing sort of mixed Linux and Windows infrastructure, both on premises and in the cloud. I'm going to hand over to JB to talk a little bit about how this miracle works.
Thank you, Oliver. So a bit of history of WSL, because WSL is a very young technology and maturing very quickly. So it's evolving very fast. The first version of WSL has been released in August 2016, with a first release in 2017. So it was a compatibility layer between the Linux kernel and the Microsoft NG kernel. And there were some limitation there. So Microsoft redesigned entirely WSL and released it as WSL2 in 2019. So there in WSL2 we use a real kernel, so that fixes most of the issue we had with WSL1. It's a fully redesigned architecture, but which brought a lot of improvement. So this is a comparison between WSL1 and WSL2. WSL1 is a compatibility layer between the Linux kernel and the NG kernel. What does it mean? It means that it translates every system calls from Linux to NG. So a system call is the interface between the application and the kernel. For example, if you do an open system call on a Linux kernel, you will pass a path to the file you want to open and a mode to open this file. Then on NT, this system call doesn't exist. You have to call, for example, open file. So then you have to translate this open call to an open file call on the NT side. So that's why this WSL layer does on WSL1. But it comes with many limitations. For example, there are a bit more than 300 system code in Linux. Not all of them were ported to WSL1. Means that many applications were not supported. In particular, critical pieces like Docker didn't work. Or if you want to trace an application, sometimes it doesn't work. So this has been fixed in WSL2 by redesigning the architecture completely and basing the architecture on Hyper-V and what is called by Microsoft a lightweight Linux utility VM. So it's a highly optimized VM in which you run the distribution completely. It's highly optimized, so it boots almost instantaneously, and it runs a real Linux kernel. So the advantage of running a real Linux kernel is that you have full support of the ABI and you have full system calls compatibility. It also increases I/O performance because you're on an exe4 file system, so you're not talking to the Windows file system. And there is also, compared to a standard VM, there is a reduced memory footprint. So fast boot, full system call, reduced footprint. That's the advantage of WSL2. You may still want to use WSL1 in several cases because not everything works as in Linux in WSL2. So, for example, if you have memory constraints, you want to use WSL1 because you're not allocating any memory. If you want to do cross-compilation between Linux and Windows using the same files on the two file system, then you may want to use WSL1 because you don't have this layer of communication between WSL2 and the Windows file system. You may want to access USB ports or serial ports. So for USB ports, there is a project called USB IP-Win, which allows you to attach a USB port to WSL2. But serial ports, there are some workaround, but it's still difficult to do. And VirtualBox, for example, there are some incompatibilities there. And with some version of VirtualBox, it may not work if you're running WSL2 at the same time. So you may want to use WSL1 if you're relying heavily on VirtualBox. So if we compare side-by-side integration between the host and the Linux operating system are the same, it boosts very quickly, so it's sub-second boot, small resource footprint. If you want to run VMware and VirtualBox at the same time, you'd prefer to have WSL1. The advantage of WSL2, it's a managed VM, so you don't have to bother with VM management tools. You have a full kernel support in WSL2, full system call compatibility, and cross-file system operation is far better on WSL1.
Jean-Baptiste explained to us why you would, an example of where we might be wanting to use WSL and VirtualBox, like what kind of workflows interact in that way.
Well, if you want to run, for example, a full OS, a full desktop environment in a VM, you will want to run it directly in a VM. It's difficult to run full, for example, Ubuntu desktop on WSL2. You don't have the shell, you don't have GDM, you don't have everything. Or you may want to run another version of Windows if you're working on several versions of the operating system at the same time. And at the same time, you're doing your development on your Windows machine using WSL. So you want to run all the environment at the same time on the same host. In this case, you may have conflicts. So I said in introduction, it's evolving very quickly. Some version of VirtualBox are working. So you have to go to VirtualBox and WSL news to see which one is working and which one is not.
Cool, I'll check that out.
We can compare the performance of WSL1 and WSL2. So this benchmark has been done by Phoronix and open benchmarking. So it's completely independent from Canonical and Microsoft. So we are not involved into that. It's done on hardware by Phoronix and open benchmarking. And here are the results they found. So these tests are pretty old, but they are still relevant. So on a set of 172 tests, we see that it's almost equivalent, but there is a small win for WSL2. So WSL2 performs better on 53% of the test. And if we compare the raw results, so the speed of the improvement between WSL1 and WSL2, we see an improvement of 24% between the two versions. And we see here also a huge difference between WSL2 and Ubuntu on hardware. But this test is 2 years old, so we'll see that WSL2 caught up a little bit, and more than a little bit actually. So this is the performance of WSL2 on Windows 11. So this is the latest version of WSL2 that you can get from the store. So it's the same test from Phoronix, so not done by Canonical or Microsoft. And you see the difference is very small. It's between 6 and 7% on average between Ubuntu 2004 on bare metal and WSL on Windows 11. We see that, for example, it really depends on the workload. If you're doing GCC compilation, for example, where you need a lot of IOs, then the difference is a bit higher. So depending on your workload, you may want to run on a VM, or you may want to run WSL, or you may want to run on hardware.
Kyle, I know you've got some graphs later, but does this performance mirror what you've been seeing at Dell?
Yeah, I was just thinking as he was talking, and in preparation for this conversation today, Jean-Baptiste and I were kind of comparing notes about what kind of performance we're seeing, and I was really pleased to see that your data is showing really that there's only maybe about a 6% on average. Your mileage will vary per workload. That you're only giving up maybe 6% of the performance of running native on bare metal, so to speak, when you're wanting the benefits of WSL. It took WSL2 and Windows 11 before it got down to that 6%. We'll show. I'll share some information in a few slides here, but we're actually seeing that the gap is a little bit closer, and the performance hit isn't 6%. It's a little bit lower than that, which was quite pleasing because WSL1 and data science model training workloads is entirely about performance. No data scientist out there is going to take a 10% plus hit in order for the convenience of being able to swap back and forth between Windows and Ubuntu Windows. So this is quite pleasing. It's pretty exciting to finally see WSL2 on Windows 11.
Cool. So obviously, WSL is often standing in place of a traditional VM. So JB, do you want to talk a little bit about the pros and cons there?
Yes. So we discussed a little bit about VM against WSL, but let's go a bit deeper into this topic. So one important part of WSL is when you want to do your job, it boosts almost instantaneously. So it's less than a second. So when you start a VM, it's up to 30 seconds, 10 to 30 seconds, depending on your machine, depending on the guest OS and so on. Then the resource overhead of a full virtual machine. So you have to allocate memory to your virtual machine. You have to allocate CPU. It's entirely managed by the hypervisor. So it loads just the memory used or required by the WSL machine. So you have lesser impact on the host. And so it means that you can load much more instances than instances of VM. Another difference are some key features that you don't necessarily have with a VM. One, interoperability and remote extensions. So what is interoperability? Interoperability is a feature to seamlessly integrate WSL with the host OS. So from Windows, you can see what's in Linux. From Linux, you can see what's in Windows. It's completely transparent. You can access It's not even like a mount point, but you don't have to mount anything. You start WSL and your Windows operating system is there. So that's for the file system interrupt. And then you have the command interrupt. So this is the magic behind WSL. You can pipe a PowerShell command with bash commands. For example, here we see a dir pipe WSL grep and git. So you run a dir command and you grep for git. Grep will be executed as a Linux command and dir will be the PowerShell command. But you can also do it the other way around. So you do execute a command inside your distribution, inside your WSL instance, and pipe it to a Windows command. You can start, for example, I would say Notepad or Explorer from Linux, but you can run any Linux command from your Windows machine. So you get the best of both worlds. Another interesting thing, you can share the environment variable between the systems. So imagine you're writing a PowerShell script, set environment variables, and then execute a bash script and see the variables from inside your bash script. So you can imagine the power to do CI, for example. So you can mix both. And then you have your development tools. So running the command line is fine. You can do many things, but then you need a development platform. So a very popular IDE is Visual Studio. If you're working on Linux, on Ubuntu, there is Snap package for Visual Studio. If you're working on Windows, you can download it from the store. And there are a lot of extensions for many languages. If you're doing Go, Python, or Node.js, everything is there. And so how does it work? If you're running in a VM, well, you can run VS Code directly in a VM, or you can run it from outside the VM and run the client, the server, the VS Code server in the VM. But it also works with VS Code Remote with WSL. It means that the front end, the UI of VS Code is running on Windows, but VS Code Remote server runs on WSL. So that gives a very high level of integration between your IDE and your development environment. And it's the same level of integration with Docker. So Microsoft has been working very closely with Docker to reach this level of integration. So there's no need for a different build script between Windows and Ubuntu. You have your scripts running on Windows. You lower the resource consumption. It starts very fast. And with this interoperability, you have your docker.exe, so your client that is on the Windows side, which will talk to your WSL distribution. So the target will be exactly the same than the target you want to deploy your Docker container to. So that's one of the main advantages of this new Docker desktop client.
We'll have a little screenshot there where you can find the settings to activate those extensions, both Docker Desktop and Visual Studio Code. And finally, we've got WSLG.
Yeah, so what is so we talk about WSL1, WSL2, and now WSLG. WSLG is not for a greater WSL, it's G like graphic. So running command line application is super, but sometimes you may also want to run graphical application. So you can run a full shell if you're feeling brave, but sometimes you just want to see a visual output of your application. For example, in the screenshot, we see the output of Octave. So what is WSLG? WSLG is included right now in Windows 11, in the preview version of WSL on Windows 11. So it's really out of the box. It's coming to Windows 10. So what does it do? It's a WSL instance that serves Wayland, Anix, and Pulse Audio server. So it's all embedded in this instance. And when you start a GUI application, it will start this instance that will display the application. So it's completely transparent to the user. Previously, on Windows 10 with WSL2, you had to set up an X server. So you install your X server, and then you have to configure your display. Here in Windows 11, you don't have to do this anymore. It's done for you by WSL. It's handled completely behind the hood. You don't see anything. And it's close to native performance. You can see the application from your start menu. So you can run your Ubuntu application like if it was a Windows application. So the startup takes a bit more time the first time you start it, because you have to start your WSL instance and then start Wayland and the server and the Pulse Audio server. But afterwards, it's almost instantaneous. So you see, for example, here for Octave, if you open your start menu, you see Octave in the start menu and you will start the IDE of Octave. So really, if you want to view the result of your experimentation or preview Linux apps in the development environment, everything is there with WSL. I won't go through the details of the architecture. So it's written here, it's come from Microsoft documentation. I invite you to read the blogs from Steve Pronovo, who built this fantastic system.
Cool. So let's talk a little bit about WSL for data scientists. And I'm really interested to hear Carl's perspective on this topic, because I think he's got lots of great insight there. Just talking quickly about Ubuntu, why, we're really proud about how great Ubuntu is for data scientists. It's a really popular operating system amongst data scientists. You can see we've got this graph here from HackerEarth. And it's also one of the most popular distributions on public clouds, particularly for machine learning. And so because of that, you're often seeing all these key sort of AI/ML toolkits like Scikit, PyTorch, TensorFlow, they're targeting Ubuntu first. And so especially in an academic situation, when you want the latest and greatest, then Ubuntu is really important for you to be able to experiment at the cutting edge. And the other thing that I think people often sort of overlook is, because Ubuntu is the target platform, when you're out there and you're looking for guides and you're looking to get started, then the documentation, the tutorials, they're all going to assume that you're working on Ubuntu as well. So I think that's another just sort of ease of use thing that I think often doesn't get acknowledged. The other thing, just to sort of highlight here, is this continuous sort of consistent environment that Ubuntu gives you. You can develop on your workstation with the target deployment platform being something like the server or cloud. But Kyle, we were talking earlier just before this about how that's not quite the whole story in that terms of that linear progression, right?
Yeah, it's less of a linear progression. In our discussions with data scientists, literally for the last several years, almost in all cases, data scientists and machine learning, deep learning, AI developers, whether they call themselves a data scientist or they go by another name, they almost always prefer to start out on a workstation. They want their own sandbox where they can make changes without having to get approvals from the admins in a server center. And they're absolutely not going to let you go in, open up a blade, change out something, put in a new solid state drive or new GPU card. Those things just aren't possible. And so they prefer to always start out on workstations. And the de facto standard, not just in the academic world where they're getting their masters and their PhDs in data science, but also out in the industry. When they graduate, they go out and start working for industry. Ubuntu is the de facto standard operating system environment that AI, machine learning, deep learning is conducted. Having said that, they data scientists go into work, and sometimes they always there's the data scientist user, and then there's the IT manager. Those are the two stakeholders in a workstation, and they don't always see eye to eye. The IT manager, the de facto standard tools for admitting and applying policies and make sure policies are not violated, is Windows-based and Microsoft environment tools, as you were kind of touching on earlier, Oliver. Meanwhile, the data scientists say, well, we come from Ubuntu environment, and so sometimes those conversations don't go very, very well on that. With WSL2 and on Windows 11, with those optimizations in there, those two worlds and those two cultures literally come together. It's Switzerland, without a performance hit, basically. The progression of the work isn't quite so linear. Things may start out on a workstation, but when they reach a point of training the model, they may decide, it's perfected already, and I'm ready to release it to all of my adoring users out there, and I deploy it across, racks and on-premise servers, or go to an on-premise cloud, or even all the way out to those IoT devices that don't have Windows but they perhaps have an Ubuntu, running out of the IoT. but they may also be deployed on the workstations. And while they're being taken to scale, they don't even need to go through the steps of going to servers or private and public cloud and things like that. So it literally gets deployed everywhere. And the cool thing here about the discussion we're having here today is that those models, those inference models that are resulting from the development of the models, those inference models, when they get deployed, they don't even have to leave the Ubuntu environment on their way out to being deployed across all these diverse platforms, whether it's on the same workstations or out there on those servers out there.
Great. Let's talk a little bit more about the performance, because I think one of the really interesting things about WSL is how it takes advantage of sort of native Windows drivers using things like NVIDIA CUDA to really sort of get the most performance it can out of this setup. Jean-Baptiste, do you want to talk a little bit more about how GPU accelerated workload work in this sort of environment?
Right. So that's one of the advantage of WSL2, and what it brought here is access to the hardware directly from inside WSL2. So you now have a driver inside WSL2 that is visible by the Linux application that has direct access to the hardware. So you can benefit for all the acceleration of your CUDA application. So you have close to native performance for GPU accelerated workloads. So for AI/ML, it really makes a difference. You can develop in WSL and have the same experience that you would have directly on hardware. It means that Windows users also have the latest framework supported by NVIDIA, and we are working closely with NVIDIA to have the latest driver available on Ubuntu as soon as possible. So when you have the latest hardware from NVIDIA, you soon have the latest driver, and you get most of the performance of their hardware. So it really reduces the overhead of having one OS to, for example, when you want to render your result, you have to use productivity suite like Office 365, and then you need a Linux machine to run your data science workload. So this way, this vanishes completely. You have one host, you can have the workflow consolidated on one single machine and work transparently between all your environments.
Fantastic. So not just not just the benefits of performance, but then the savings in the speed of the workflow, switching between operating systems, number of devices you need to have to hand. But let's go back to these benchmarks, Kyle.
You bet. And our measurements and our performance analysis, reflected what it is Jean-Baptiste has just been indicating here. So I'm really proud to be able to report that and confirm. Everyone's mileage does vary. The nature of doing machine learning and deep learning model training is absolutely almost a poster child example of high performance computing. There's not a data scientist or an AI model developer that couldn't use more memory, whether that's CPU memory or in our case, GPU memory, where most of the training model heavy lifting is being performed. More CPU cores or more GPU cores or more memory. They've always want more if they can get it. And it's a question of how much can they afford, and the IT managers will release to them to use. They aren't so much on file system calls. They'll open up a file system request and dump in huge amounts of data in the CPU memory, and they try to minimize the I/O calls in general. And each one of those is a huge I/O file where the data is dumped into CPU memory and applied its way over to GPU memory. So there's that one unique aspect about data science model development. That indicates to us that it's not so susceptible to the file system calls that Jean-Baptiste was mentioning earlier, the difference between WSL2 and WSL1. Having said all of that, we wanted to use a workload that demonstrated maybe one of the heaviest uses, and doing image classification, deep learning algorithms to train the TFCNN widely known workload for doing image classification. And the results that we're showing here indicates that when running on the WSL2 stack, that the image recognition or classification algorithm, the TFCNN performance, is either the same or is within 4%, which means you're not giving up much performance at all by running in this so-called virtual WSL2 environment. It's almost as if you were running on bare metal, and those I/O calls are going direct. The I/O calls to memory allocation and the device drivers for the GPUs to be doing all the heavy lifting. It's as if you're running on bare metal. The data that we're showing right here, and it's just a snippet, was literally running on a mobile data science workstation. It was our 15-inch latest DSW precision workstation. It has an Ampere class 85,000 RTX GPU. The numbers that we got for the A6000, its big brother on a fixed workstation, they were almost identical. So the data scientist users out there can expect that with WSL2, certainly in the Windows 11 environment, that they're really giving up hardly any performance at all in their pursuit of trying to combine these two worlds. And so now, finally, they don't have to, shut down and reboot to get to the Windows tools and the Windows admin tools, that the IT manager tells them that they need to have access to remotely anymore, and then reboot over to Ubuntu. They literally can open up the Ubuntu drivers and do their machine learning training runs.
Great. So we're pretty much getting close to the end of our time. So let's just talk a little bit about how to get started. Back to you, Kyle, I think, with this slide.
Well, we've touched on the performance and what problem WSL2 finally does resolve. I wanted to point out that the Dell Precision Workstation product line, we have integrated and pulled together validated platforms called Data Science Workstation. These are all certified by not just NVIDIA and Dell, but also our esteemed colleagues at Canonical, making sure that these data science workstations, whether they're mobiles or whether they're fixed workstations or even the rack versions, they're available to run AI workloads in the training run the day that it arrives. And WSL2 now gets to be added to the equation here. And whether you're an AI developer and you're doing the development of the models, or whether you're an AI user that the inference models that result from that get deployed onto, this is kind of the portfolio of the data science workstations that we have available. And all of these that we're showing here and the Ampere class RTX GPUs that are available as part of those data science workstations. So really pleased with the collaboration between all three of our companies to get to this point, particularly with WSL from Microsoft.
Great. So if you're a user, you can get started with WSL through these two routes. So it's very easy to get WSL set up. If you open up PowerShell and you do WSL --install -d -Ubuntu, that's your quickest way to getting Ubuntu ready on WSL. If you like the GUI route, then you can find WSL in the Windows Store, and then once you've installed that, you can find Ubuntu. If you want more sort of information and documentation on how to get started with Ubuntu on WSL, obviously ubuntu.com/WSL should be the place to go. We're adding new tutorials and updates and blog posts on that topic regularly. We also recommend checking out the excellent Microsoft documentation around WSL as well. They've got some really great insights there, especially around the technical implementation. Kyle, where can you go to find out more when it comes to Dell?
Well, for the data science workstation solution, we've got a couple links there to go browse the actual products available, and also for more information and white papers, technical, and the benchmark performance analysis briefs that we do have. I did want to point out that be sure when you get your data science workstation or have access to it and you're ready to install the NVIDIA software stack for that, be sure that you install. We've got white papers there that steps our customers through installing the proper WSL image of your Ubuntu. and then get on with downloading the NVIDIA DataSite software stack once that step has been completed. So I would just remind everybody in the audience to be sure and follow Oliver's instructions to install the WSL version, of Ubuntu on their systems. So that's where the information from Dell is. Of course, here's links for NVIDIA and for Canonical as well.
Fantastic. So that brings us to the end of the presentation portion of the webinar, and we're looking forward to answering some of your questions in the Q&A section. Seems like there's quite an appetite for pros and cons and comparisons still. So JB, I'll throw you a couple of good ones. The first one was WSL versus POSIX. Do you want to maybe talk a little bit about what POSIX is and how that compares in terms of people's workflows?
Okay, so POSIX is a standard for essentially system calls and implement all the interface between the kernel and the user space. So the thing is between WSL and the implementation we had in WSL1 and now what we have in WSL2, that you had to translate all the system calls from Unix, from Linux to NTNs. It doesn't really match, so you cannot do a one-by-one migration or conversion of all the POSIX calls to the NT kernel. So that's why there was a lot of limitation. For example, you couldn't run Docker and WSL1. Some codes were not supported, and that's why also Microsoft put so much effort on writing WSL2, which is now based on VM technology and use a full kernel. So you have the entire stack of system calls available. So you get rid of all these limitations.
Great. And the other comparison, while we're doing comparisons, was versus the Linux Hyper-V VM.
Yeah. So with WSL2, it's what is called a lightweight utility VM. So it's a VM really optimized for the specific case of WSL. So you don't have the full experience of a traditional VM. It's still using Hyper-V, but you don't have to go through the entire process of, first, you don't have to install the VM, go through the installation process, and you don't have the entire boot process. And other thing you would have, all the experience you would have with a traditional VM. It's really optimized for reduced footprint, very fast boot speed, and then all the life cycle management of the VM is done by Hyper-V and WSL. So it's completely transparent. For example, when you're in traditional VM, you have to shut down your VM when you're done. In WSL, you start your work. It starts in a couple of seconds or sometimes sub-seconds, depending on your system. You do your work. When you're done, you just exit the console, and 1 minute later, the WSL engine will shut down the VM automatically to release the resources allocated to the VM. So that's the main difference between WSL, where everything is done transparently for the user, and a traditional VM where you have to manage everything yourself.
Cool. This might be one for you, Kyle. But one of the comments was about the performance difference between WSL on Windows 10 versus 11, and I think you made a comment earlier about Windows 11 performance being quite increased, and your particular benchmarks show a notable improvement on some of the Phoronix graphs that we were showing.
Yes, that's actually a good question. The reason why we try to state the facts whenever we have a performance metric that we put out there, even a snippet like this. So the only thing to take away from that is that we had measured it on Windows 11. We have yet to run it, kind of retro run it, on Windows 10, because Dell, we're rolled over to Windows 11. So it's not that that it's any different. In fact, we anticipate that it's the same as if it was running on Windows 11 back on Windows 10. It's just that we had not measured that, and I certainly didn't want to make claims, that said that, hey, you're good to go. I would encourage users out there, have the confidence. It gets 2 thumbs up from our first look at Windows WSL2, and that they should proceed with the instructions that you provide and Microsoft provides, for adding it to Windows 10, and have confidence it's going to their mileage is going to be about the same as what we've seen.
Yeah. And there's another question about sort of customers and how they get used to the idea of Linux and Windows working together, and that sort of match. It's maybe not a relationship you might have expected a few years ago. Things are changing now. How do you sort of explain that to the data science customer?
Well, humorously, we would say, hey, it's like you woke up one day and dogs are living with cats, or vice versa or so. But quite a few of the data scientists that we've talked to, they're already quite familiar with Windows as well as Ubuntu. And they're well versed in both worlds. The only difference now is you don't have to configure a dual boot system to go back and forth between the two worlds. You don't have to. All you need to do is drag your mouse over and click on what happens to be a Windows window instead of that. And so it's not that big of a culture shock, or a technical shock. I think what is interesting after hearing Jean-Baptiste talk about it earlier today is that it's astounding to me, at least, and I think the data scientists will at least get a smile on their face when they realize that, wait, did we hear Jean-Baptiste say that right, that I can actually issue a command shell line within a Windows window? And that's a pretty clever trick. So I think it's going to pique the curiosity of data scientists that aren't already well versed in both worlds through dual boot systems that they've been constructing and maintaining all along.
Great. JB, a couple more questions for you. I think there was one about drivers, because when we were talking about the NVIDIA CUDA, there was maybe it wasn't super clear whether that's leveraging the native Windows drivers, or you need the hardware drivers for Linux as well. How do those work a bit together?
So the only driver you need to install is a Windows driver. Then it will expose a node or driver inside WSL, which will be the XG driver that will allow you to access the hardware. But the only part of that you have to install is the Windows part.
Fantastic. And there was another question about multiple GPUs. We haven't really talked about that. Kyle, do you want to talk about multiple GPUs when it comes to data science?
If I understand the question correctly, multiple GPUs meaning, hey, how is it with whether there's just one GPU card in the system, or whether there's a second or a third or a fourth or n number of GPUs? We have had some performance analysis, and we've run on not just a single card configuration, but dual and triple cards and beyond. And one of the things that we did notice was that while you're able to achieve within 4% of the performance versus native with one GPU in the system, if you go to a second and or a third card, something like that, that is no longer the case. You're no longer falling within 4%, or matching the performance as if it was running natively instead of on WSL2. So I've had recent conversations. Jean-Baptiste, I know that you're in constant contact with Microsoft engineering as well. And we have a conversation starting with them about, okay, when can the market expect this same performance, whether it's one GPU or whether it's second, third, and fourth GPUs? Can you rack and stack these things and still and scale linearly on that? In the meantime, though, I would encourage data scientists and users of Ubuntu to go ahead and evaluate and actually get used to single card configurations in anticipation that there will be additional features in the future. Watch this space from Microsoft and Ubuntu and Dell for when those additional features like multiple GPUs are going to be basically ready for market.
Fantastic.
And that's whether it's training workloads or whether it's inference loads. Either way.
Cool. I think we're just about out of time, but maybe one more question. We were talking. There was one about GNOME maps in WSL2. Is there more to it than just WSLG? Very big.
Well, graphical apps in general, especially WSL2 on Windows 11, you have WSLG, so it works out of the box. Then you need, for GNOME apps, you need a little bit more than just an X server. So you need systemd, you need dbus first, and for dbus you need systemd, and it's not available by default on WSL. So that's one of the things we are working on at Canonical, and something we plan to release for 2204 is systemd and then dbus support that will allow users to run a broader range of graphical application on Ubuntu on WSL. So stay tuned. That's very soon.
Fantastic. I can't wait to hear more about that. Great. Well, that's all we've got time for. So thanks everybody for coming. Thanks for all the questions. Apologies we didn't get to go through all of them, but hopefully we hit a good range. And yeah, that's it from us. So take care and have a great rest of the day.